Frenchman Joseph Gay-Lussac studied the properties and reactions of gases. In 1809, he stated his laws of combining volumes, which is, volumes of gases taking part in a chemical reaction show simple whole number ratios to one another when measured at the same temperature and volume. In other words, gases react in simple whole ratios. For example, in the movie The Martian, Matt Damon synthesized water by reacting hydrogen gas with oxygen gas, according to the chemical equation. 2 volumes of hydrogen gas react with 1 volume of oxygen gas to give 2 volumes of water. So if we had 60 ml of hydrogen gas, it would react with 30 ml of oxygen gas to produce 60 ml of water. These volumes are consistent with the stoichiometry of water. In fact, Avogadro improved on this law in 1811, who stated, equal volumes of all gases at the same temperature and pressure contain equal number of particles. For example, 9 particles of argon gas and 9 particles of carbon dioxide gas occupy the same volume when at the same temperature and pressure. Particles could also represent molecules or moles. This is a pretty big discovery, so knowing the mass of a gas allows us to calculate its volume. So here's the next concept. The molar volume is the volume occupied by 1 mole of any gas under given conditions. The molar volume, Vm, is measured in liters per mole. Or in other words, molar volume is the volume of any gas at a specific temperature and pressure if we had a mole of it. So what we know is that at 0 degrees Celsius and 100 kPa, the molar volume is 22.71 liters per mole. That is, 1 mole of any gas at these conditions will have a volume of 22.71 liters. Hence its units are liters per mole. Similarly, at 25 degrees Celsius and 100 kPa, the molar volume is 24.79 liters per mole. Let's apply it to an example. A bottle of Pepsi Max has a mass of 632.45 grams. When the cap is removed and left off for a while, the mass dropped to 631.05 grams. Assuming that the mass loss was just carbon dioxide, what volume of carbon dioxide has been lost at 25 degrees Celsius and 100 kPa? So we need to calculate the difference, which is initial mass minus final mass, giving us 1.40 grams. We'll convert this to moles, which is mass on molar mass, giving us 0.0318 moles. Now we know that 1 mole of any gas at these conditions gives us 24.79 liters, but we don't have a mole, we only have 0.0318 moles. So all we do is multiply these two numbers, which gives us 0.788 liters. Remembering that the answer will always result in liters.